Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 8, Drawing Triangles. Classwork Exercise 1 and 2. Okay, it says to use your protractor and ruler to draw right triangle DEF. Okay, use your protractor and your ruler. Here's my protractor, here's my ruler. All right. Label all sides and angle measurements. Predict how many of the right triangles drawn in class are identical to the triangle you have drawn. So to draw a right triangle, we have to start with a side. So I will draw a side, and I'll go from 0 to 5. Okay, so this is 5 centimeters. I'm going to call this A. I'll call this B. I then take my protractor and I can either put it at A or B. I'll just put mine at A. And you need to make sure it's accurately placed. You want your crosshairs right on the point A, and you want the line that's on your protractor from the crosshairs over to the 0 degree symbol or over to the 180 if you chose the other side to be right on this line. Okay, so now I just have to go up and mark on my paper where 90 is, which is right there. Okay, right there. So then I move my protractor out of the way, I bring my ruler over, I rotate it, and I put it on A, going up and draw a line through, and I don't have to go all the way to my point. All I have to do is go in that direction, and I'll stop at the word how, so I don't draw through the question. So there is my C right here. Now all I have to do is connect C to B. So I put my ruler on C and rotate it so that it goes to B. Okay, and this is the right angle. Okay, so there is drawing a right triangle. It did not say to give angle B a certain measurement or angle C. It just said to draw a right triangle. So one angle has to be 90 degrees. The other two have to be acute. Okay. Well, in answering the question, how many are exact, what does it say? Predict how many of the right triangles drawn in class are identical to the triangle you have drawn. Well, if you're not talking about distance, and you didn't put that there, then they would all look like this, or they could be reflected. So it could look like this. Okay, so it could get flipped like so. Of course, my C and my B are backwards, but it could look like this as well. You could have gone the other direction. Okay, so either that or I'll flip it back. Okay. B says, how many of the right triangles drawn in class are identical to the triangle you drew? Were you correct in your prediction? So drawings will vary, and most likely a few or none of the triangles in the class are identical. So someone could have drawn the line they could have drawn it like this, where the right angle's up in the top right corner. There's many ways we could have drawn this. It could have been drawn this way, or even this way. Okay, so the chances of them being identical and having the same side lengths is pretty slim to nil. So I would say they're not identical, they'd be similar. Number 2. Given the following 3 sides of triangle ABC, use your compass to copy the triangle. The longest side has been copied for you already. Label the new triangle A prime, B prime, C prime, and indicate all side and angle measurements. For a reminder of how to begin, refer to Lesson 6, Exploratory Challenge, Problem 10. Okay, so the first thing I'm going to do in this problem is I'm going to measure each one now. And I'm going to put my ruler right here. Obviously, my measurements are going to be different than yours. You are on paper. Mine is an electronic copy, which probably isn't scaled the same. But I would say that, and I'll do millimeters. This is out to this 2 after the 4, so that is 42 millimeters. So AB is 42 millimeters. And then I will measure BC. And that is 64 millimeters. And then I will measure AC. And that is 86 or 85. 85. I'll say 85 millimeters. Now if I come down here and measure AC down here, the one that's already been copied for us, it should be the same. And there it is, 85 millimeters. Okay. All right, so I'd probably want to move that down below because we're creating a triangle. So it said to name this new triangle A prime, B prime, C prime. So I will put prime markers on A and C. And so all I need to do now is take my compass and bring it down here. Now remember, if we drew a circle with our compass, then we would form a circle with a radius, and if that radius is the length of this segment, then I can draw a circle over here. So I have a point A, I have a point C. I already have side AC, I don't need to copy it. So I will put my compass at A. All right, let me switch to my pointer here and get this accurate. Right there on A. So I put my compass point on A. I open my compass up so that my pencil is as close to B as possible, which is right about there. I'll change the color of my pen to, let's see, hello. How about purple? So what I'm saying is, if I now rotate this, okay, so as you can see, if I drew a circle, AB would be a radius, wouldn't it? Okay, so then if I move my compass over to A and I drew a circle, very difficult electronically, okay, and drew a circle here, that circle is identical to this circle over here with a radius of AB. So anywhere I can draw AB anywhere here. So I could, I'm going to erase this, but I could draw a segment AB from here over to here, or I could draw it over to here or over to here. Somewhere, anywhere around here will create a triangle as long as I'm BC distance away. Okay, so it's somewhere on this circle AB has to be, but I'm not sure where yet, so I won't draw that. I then take my compass and put it right on C prime, or C. Rotate it so it's flat, open it the other way, and then put my pencil right on B. I'll change the color to blue for this, and as you can see, if I drew a circle, that is a circle with radius of length BC. So if I put my compass right here on C prime, and we want to be as accurate as possible, that looks pretty good right there, and then draw a circle all the way around like that, okay, then you see that this circle would be identical to this one, same radius anyway. Okay, so now that I've used my compass, I can get rid of that. So what have we done here? Well, we've found where the 2 points intersect, where the 2 radius would come together, and that would be my B prime. There's B prime. So now all I have to do is draw a segment from A prime to B prime, and from B prime to C prime. And there is my triangle where A prime B prime is 42 millimeters, and now I'm going to check it. So I'm going to grab my ruler and put it right on A prime, rotate it up, and there's B at 42. Right there is 42 millimeters. Now if I rotate this the other way and put my ruler on B and measure down to C, it is 64 millimeters. So here is a triangle, A prime, B prime, C prime, with side lengths that match AB, BC, and AC. Okay, exploratory challenge. A triangle is to be drawn provided the following conditions. The measurements of two angles are 30 and 60 degrees, and the length of a side is 10 centimeters. Note that where each of these measurements is positioned is not fixed. How is the premise of this problem different from exercise 2? Okay, so in exercise 2, we drew a triangle with 3 provided lengths, while in this problem we are provided 2 angle measurements and 1 side length. Therefore, the process of drawing this triangle will not require a compass at all. Okay, but what will it require? Okay, well, we need a ruler, so I'll take my ruler. And B says, given these measurements, do you think it will be possible to draw more than one triangle so that the triangles drawn will be different from each other? Or do you think attempting to draw more than one triangle with these measurements will keep producing the same triangle, just turned around or flipped about? Okay. Okay, so answering this question, responses will vary. Possible responses would be, I think more than one triangle can be drawn because we only know the length of one side, and the lengths of the 2 remaining sides are still unknown. Since the 2 side lengths are unknown, it is possible to have different side lengths and build several different triangles. Okay, so that's one possible response. So C says, based on the provided measurements drawn, draw a triangle ABC. So angle A is 30, angle B is 60, and side AB is 10 centimeters. Describe how the 10 centimeter side is positioned. Okay, so that's what I'm going to do first. I'm going to draw a 10 centimeter side, and I'm going to call it AB. So I start at 0, and I go over to 10. There's my 10 centimeter side. This is A, and this is B. And it's 10 cm. Okay, so I drew the side. That was easy. Okay, but what do we need to draw angles? Well, we need a protractor. So if I go get my handy dandy electronic protractor and bring it down here, I want to put it either at A or B, it doesn't matter. And I'll put it at A. So I make sure my crosshair is right on the end point of this segment, and this segment is right on this line that's measuring 0 degrees on the protractor. I then want to go up to the 30 degree mark, which is right by this 150 here, and put a dot. I then move my protractor out of the way. I bring my ruler over. Okay, and I want to put that right on 0, right there. Rotate it up, like so, and I will draw a segment. Okay, I don't know how long it's going to be, so I'll just draw a really long one like that. Okay, so there's angle A right here, and it is 30 degrees. Okay, now I need to measure of angle B 60 degrees. So I take my protractor and I put it right on B as carefully as possible. Okay, right there. So it's right on B, and my line segment AB is right on this 0 or 180 degree line segment. And now I want to measure over 60 degrees, which is going this way, opening up to 60, which would be approximately here. So then I move my protractor, bring my ruler down so that 0 is right here. Whoa, what happened there? Extended page, I think. Okay, and right there. Rotate this and go through this point right here. And draw a line up to that point like so. Okay, so there is a triangle. This I know is 60 degrees right here. I just used my protractor to create it. And where those two line segments meet is point C. Okay? So yes, I could have done one the other way so that this was my 60-degree angle and this was my 30, and then it could be rotated anyway. But if this is 10 centimeters, that is an angle side angle situation. And in order to create any triangle with 30 here and 60 here, or 30 here and 60 here, and this being 10, these two lengths will be fixed. So there will only be a few possible outcomes, and it would just be differed by rotation and reflections. But there is my triangle. And the 10 centimeter side is positioned between points A and B. Okay, D says, now using the same measurements, draw a triangle A prime, B prime, C prime, so that we have this scenario. Describe how 10 centimeter side is positioned. So again, I'm going to get my ruler, and I'm going to draw AC first, and it's going to be 10 centimeters. So I start at 0 and I go out to 10. That wasn't quite long enough. Out to 10. There, that's good. Label it 10 centimeters. And it's called AC. So if I make this A and this C, then I want angle A to be 30 degrees. So I get my protractor. Put it right on the end here. Okay. Make sure the crosshairs are right on A, and be sure that AC is right on that 0 degree marker. And I want angle A to be 30 degrees, so that's out to here. Okay. Then I take my ruler, place it right on A, rotate it, draw a segment up like so, label this as angle A being 30 degrees, and then move my protractor to C like so. Need to move it down just a little. Okay, right about there. We're right on that 180 or 0 degrees line right here. And now I want 60, which is over here. I'll use green for this side. So here's 60 up here. Take my ruler, put 0 on C, rotate it around, find that point, and draw. And there's my B. And this is... Oh, I made a mistake. Disregard that. It's the last step. Okay, and notice I caught myself though, because it says AC is 10, angle A is 30. We want angle B to be 60, not angle C. So I want a 60-degree angle on this side somewhere that would make AC 10 centimeters. Okay, so I need my protractor to be on this red side somewhere. I need to rotate it around so that I'm right on it, like so. And then I need to be able to find where, and I need to make a 60-degree angle. All right, so this will help if you have this on your protractor. Okay, so there's a 60-degree angle right here. Where did it go? Right there. That is 60 degrees here. So if I move my protractor now, I would have to slide it up so that I find where it would reach that 10 centimeter side, C. So I put my protractor on and then I slide it over and now I can see it's got to go all the way out to here. So now I know my vertex is up here at this point. So I'll just draw a line, a mark right here and a mark right here. Move my protractor and take my ruler starting at C and work up, and I need to extend this red side. I should have made it longer. And there is B right here. And B is 60 degrees. So that makes our C 90 degrees. Okay, I also could have done it that way. I could have done a 90-degree angle off of this. That's probably the better way to do it rather than trying to find. So let me just show you that. All right, so say I drew AC and I knew it was 10 centimeters. That was this first step. Then I used my protractor and I made a 30-degree angle. I should have drawn this red line all the way up like so. And then I could have taken my protractor and found where 90 degrees is. How do I know that that's 90 degrees? Well, when you have a 30-degree angle here and a 60-degree angle here, and triangles have 180 degrees, then the triangle sum theorem says that angle C has to be 90 degrees. Okay, so then I could have taken my protractor and found 90 and put a mark here, and then drawn a line segment from C up to here and found their intersection point if I had drawn the red line longer and the green one longer. Okay? All right, so part E says, lastly, again, using the same measurements, draw a triangle A double prime B double prime C double prime so that A double prime is 30, B double prime is 60, and B double prime C double prime equals 10 centimeters. Describe how the 10 centimeter side is positioned. So I'm going to start with the 10 centimeter side first, and I'll draw it 10 centimeters long, like so, and that is B double prime, C double prime, and it is 10 centimeters. So that part's done. I now will make angle B, because there's no angle A, it's up in space somewhere. Angle B 60 degrees, so I take my protractor, put it right as close as I can to the point B so that my line is right on 0. And I want 60 degrees, which is over here, and I'll put a mark on there. And then I'll move my protractor, I'll put my ruler at 0, rotate it, so I'm going through this, like so. And this time I'm going to draw a longer segment. So I'm going to go way up here. Okay. So A is somewhere on this. A is 30 degrees. B double prime was 60 degrees. So I'm going to use 2 markers for that. A double prime is 30 degrees and it's up here somewhere. So I know C is 90 degrees. Okay, so if I put C right here, if I put my protractor right on C, like so, and I find 90 degrees, which is right here, I'll do it in blue. There's 90 degrees. Move my protractor. Okay, the problem here though is we're going to run out of room. We're going up into this other problem. So let me get it out of the way. Okay, I don't want to erase that, so let me just do this. Okay, so I got that stuff all out of the way. And let me put my ruler back on there, over here. And now that I see that it has to be longer, I'm going to extend this side. Way up like so. Then I'm going to take my ruler, rotate it, and I think I erased my point by mistake. So let me put this back here. 90 is right here. Put my ruler on my paper right on C and draw a segment from there up through this point right here and continue. And then that's where they intersect, and there is my A double prime. This is A double prime right here. So I can erase my overlap. And that is 30 degrees because this was a right angle. Okay, so describe how the 10 centimeter side is positioned. All right, so there it is. So now the 10 centimeter side was the shortest leg because it's between the 60 and 90 degree angle. It's opposite the smallest angle, so it's the smallest side. So therefore it made this triangle huge. Okay? Those are more on this page. F. Are the three drawn triangles identical? Justify your response using measurements. Okay, so we need to measure all these. Okay, so it's right at 0. I measure up to here, and it's 165, 6, 7. Looks like 168, or 16.8 centimeters. And this B prime, A prime over here, if I measure that, that is 196 or 19.6 centimeters. Okay, so I'm going to write this down. A double prime, actually side A double prime, B double prime equals 19.6 centimeters. B double prime, C double prime equals, that's this one here, 10 centimeters. And A double prime, C double prime equals 16.8 centimeters. Okay, so I'm going to put these responses down here. Okay, so I went back in time in the video to bring this back, and there's one thing I didn't do when I labeled these. This is A prime, this is C prime, and this is B prime. So now I'm going to measure all three of these. So AC is going to be 10 centimeters, okay, just double checking that, okay, and okay, so here's the measurements from the first triangle that is now partially gone because I backed up the video. A double prime, B double prime, so I want A prime, B prime measurement, I want B prime, C prime, and I want A prime, C prime, and that's from part D. And A prime, C prime was the given 10 centimeters. So this was 10 centimeters this time. Okay, now I need AB and BC. All right, so A prime, B prime is 11.5 centimeters. So A prime, B prime is 11.5. Okay, and then finally, rotate this up and move it over here and do a quick measurement, and that looks like 56, roughly 56 or 5.6 centimeters. And now I want to go back and measure A, B, BC, and AC from the previous page. So I know AB was 10. That was our given. So AB was 10 centimeters. So I want to point that out to you here. Here's my 10 centimeters, here's my 10 centimeters, here's my 10 centimeters. B double prime, C double prime, A prime, C prime, and AB. So the three possible locations for the 10 centimeters. So one side was always 10 centimeters in each of the three triangles, but what were the others? All right, so this one was 5 centimeters, and that was BC, 5 centimeters. And then AC was, and these are approximations, by the way, because we'd have to use the Pythagorean theorem to make sure we were exact. And that looks like 87, 8.7. Okay, that took a little while, but look what happened. We have three different triangles. One side was 10 centimeters in all three, but 19.6, 16.8 was the big triangle, and then 11.5, 5.6 was a medium-sized triangle, and then when AB was, when 10 centimeters was the longest of the three sides, then the other two sides were shorter, 5 and 8.7. In this one, it was the middle length. It was between 5.6 and 11.5, and in this one, it was the shortest side. So all three triangles are not identical. They have different sizes. All three angles are the same, but the sides are different. Therefore, they are similar, but not identical. G says to draw another triangle, triple prime, with these situations. B triple prime is 30, C triple prime is 60, and BC is 10. Is it identical to any of the three triangles already drawn? All right, so the first thing I'm going to do is draw the triple prime BC. So I take my ruler, draw a 10 centimeter segment, call it B triple prime, C triple prime. I then get my protractor, put it right on B. See, once you get used to doing this, it's fairly quick. Okay, and I want the angle at B to be 30 degrees, which is right here, so I'd put a dot right about here. Rotate my ruler so that it's going through the point B and that point that I just found with my protractor. And I'm going to measure it at the same time. By the way, that's 10 centimeters. Okay. Beautiful, right there. So I'm going to draw this up like so. I don't know how long to make it, so I'm just going to keep going. And then I put my protractor on C because that's the 60-degree angle. Protractor's right on C. 60 degrees is right up here, so I'm going to put a dot there. I'll use a different color for this. I will put my protractor ruler here. Put this right at 0. And go through this point right here. Like so. Here's A triple prime. Now if I measure that distance right there, should have done that before I move my protractor, so I will put it back right there, it's easier. All right, that's exactly 5 centimeters. And this is A triple prime. Then I want to measure what it is from B to A triple prime. And it's 85, it looks like, centimeters. I may be off a little. So if I go back 5, 10, 85, I think I remembered 87. 5, 10, 8.7. So that's probably 8.7 if I were more accurate. Okay, so anyhow, I already knew that's what was going to happen because B triple prime, C triple prime was 10 centimeters. And if I go back to my original, AB was 10 centimeters. So if A triple prime, B triple prime is 10 centimeters, these two have to come out to be the same. So therefore, this triangle was identical to our original triangle ABC. Part H says, draw another triangle that meets the criteria of this challenge. Is it possible to draw any other triangle that would be different from the three drawn above? Okay, so the answer to this question is no. If the triangles were identical, then the 30-degree and 60-degree angles would match, and the other angles, angle C, C prime, and angle C double prime, would have to match too. The side opposite angle C is 10 centimeters, so the side opposite C double prime is between 11 and 12 centimeters, and the side opposite C double prime is 20 centimeters. There's no correspondence to match up all the angles and all the sides, therefore the triangles are not identical. Okay, I think that's the answer to F, if I read correctly. Okay, that would go here. Okay, so they were off a little. All right, so H says to draw another triangle that meets this criteria. Is it possible? So I brought in the wrong answer, so here's the correct one. Okay, the answer is no. It will be identical to one of the triangles above. Even though the same letters may not line up, the triangle can be rotated or flipped so that there will be some correspondence that matches up equal sides and equal angles. In other words, if we created a triangle with two given angles and one given side length, the possible way to draw that, there would only be three triangles, three different distinct triangles. Okay, lesson summary in this situation is blank. So it says the following conditions produce identical triangles. Okay, 3 angle measurements and 3 side lengths is our criteria. And with this triangle here, where the base is 17.4 centimeters, one leg's 10 and the other one's also 10, we have two 30-degree angles and one 120-degree angle. So that is an isosceles triangle. There's only one triangle with side lengths 10 centimeters, 10 centimeters, and 17.4 centimeters with angles 30, 30, and 120 as arranged above. So if we have 3 angle measurements and 3 side lengths, you can only have one triangle. And that is the lesson summary. So go do your problem set.